Hey guys, today we'll be solving the differential equation dy by dx is equal to sine cube x cos square x plus x e raised to x. So the main aim of the equation is to remove the differential term and to bring the equation back in the terms of y and x. So for that we are simply going to be integrating both sides with respect to x. So we directly get y on the left side, and the only task left is to integrate the right side with respect to x. So this becomes y, and I'll separate this into two separate integrals. The first integral, I'll write it as sine x into sine square x into cos square x dx. And the second integral will be written as x into e raised to x dx. So for the first integral, I can write sine square x as 1 minus cos square x using the trigonometric identity sine square x plus cos square x is 1. This remains as cos square x. The second integral will solve it by parts, but let's just go through the first integral first. So now I'm going to be expanding this. So we have sine x into cos square x dx. Then let's just take out the minus sign. Integral of sine x into cos raised to 4x. I've just opened these two brackets and then separated it into two different integrals. We'll just keep this third integral aside for now. Okay, so now I'll just replace cos x with t, which implies that dt by dx is equal to minus sine x. Okay, so in our integral we have sine x t square dt upon minus sine x, because here dt upon minus sine x is equal to dx. So we replace this dx with dt by minus sine x. Sine x gets cancelled. We're left with minus t square dt. Now we have minus the integral of sine x t raised to 4 dt upon minus sine x. Again, sine x and sine x will get cancelled. This integral remains as it is. So we have the integral of minus t square dt. Let's just take this minus sign inside so that minus and minus become plus. So we have plus. Let's take the minus sign inside. Minus minus becomes plus. So we have t raised to 4 dt plus the integral of x e raised to x dx. Now this just becomes minus t cube by 3, simple integration, plus t raised to 5 upon 5 plus the integral of x raised to x into e raised to x dx. Now we bring t back into the terms of cos. So we have y is equal to minus cos cube x upon 3 plus cos raised to 5 x upon 5. Now using the LIATE rule and the by parts formula, u into the integration of v dx minus the integration of differentiation of u into the integration of v dx is equal to the integration of u into v dx. So here, using the LIATE rule, we have the algebraic term as x and we have the exponential term as e raised to x. If you're not too familiar on how the LIATE rule works, you can check out my video. It's linked in the description box. So let's just use this rule to solve this integral. I'm going to be placing u as x. So this becomes x into the integration of e raised to x minus the differentiation of x is 1. So this becomes 1 into the integration of e raised to x dx. Alright, so we have y is equal to minus cos cube x by 3 plus cos raised to 5x by 5. The integration of e raised to x is e raised to x itself. So we have plus x e raised to x. Integration of e raised to x is e raised to x. So double integration also remains the same. So this becomes minus e raised to x. And in the end, after integrating all terms, we add a single arbitrary constant. So I'm doing plus c. Now as you can see, there is no other integral term and there is no differential term. So this becomes our final answer.